Good morning, good afternoon, and good evening to you all, my fellow mixed reality enthusiasts. Thank you so much for taking the time to be here with me today as we talk about how we're using mixed reality to bring people together like never before. My name is Minymoh, and I'm a software engineer on the Microsoft Mesh team based out of Lagos, Nigeria. Today, we'll explore together what it takes to use mixed reality to create and share immersive experiences. We'll talk about the vision and the potential of immersive mixed reality. But vision and potential only get us so far. So we'll also dive deep into what it takes to bring that vision to life, to fulfill the full potential of mixed reality. We'll talk about the challenges that we might face in trying to bring this vision to life, and we'll talk about the tech that we leverage when we meet some of these challenges. So, what is the potential for immersive mixed reality? Well, it allows us to share our perspectives in novel ways. It allows us to deepen our understanding of the world around us and those that are in it. It also enriches our lives, allowing for new mediums for creative expression. Let's take a look.
Connection is a spark that gives our lives meaning. It drives us to seek out others who feel the same way.
Okay, why don't you input the data and we'll take a look together. Hey Mari, what you got for me?
To find those who share our views, yet offer different perspectives.
So this net. Look over here.
Challenge us with new ways of seeing.
That I think we should
Deepen our understanding. And enrich our lives.
最后一笔的时候，往前。
Great things happen when we commit to something bigger than ourselves.
Let's take a closer look at it.
Place this here. Let's see how we go from there, okay?
This sense of collaboration and the feelings of connection it brings excites us.
Hey, just in time.
I'm gonna move it slightly, okay?
It's yours, take it.
We have two planes right now on the same trajectory.
As we put people first, technology fades into the background and feels like anything but.
Aisha, what do you think?
I think if we had 330, maintaining 2800,
We'll be clear for approach.
Excellent.
This changes the way we see the world, and in turn, changes the world we see.
These numbers are looking great, actually.
There's promise in the possibilities, and what we see and create next will stretch the imagination.
Good morning, Sarah.
Morning.
Slowly coming towards the thumb.
A world without boundaries.
Good job. A lot better than yesterday.
Yeah.
Excellent. Slowly bring the
A
arm
world
down.
where technology enhances, not limits, humanity. With people front, center, and in the spotlight. The future is here. And here can be anywhere.
Here can be anywhere. I love that video, and I love this tagline. Here can be anywhere. It succinctly captures the vision that we have for immersive mixed reality. But what does it mean? How do we make that happen? Well, when I think about here can be anywhere, I think of these three things. First, I need to be able to feel your presence with me here in order for us to have an immersive shared experience. I need to feel that you are here in the room with me. This also means that we need some sort of shared here where we can both go to experience things together. Which brings me to the next point. We need to be able to experience things together in meaningful ways. We need to have interactions with content that really make us feel that we're experiencing that content together. And lastly, when we say here can be anywhere, the anywhere part is very important. We need to be able to join that shared here from anywhere, any platform, any device, and anywhere in the world, from Lagos to Dubai to Dublin to Redmond. Let's talk a bit more about each of these pillars. First, feeling presence. How do we create that feeling of presence? What do we really need? Well, first, we need a way to identify and represent users in immersive mixed reality experiences. So, in multiplayer gaming, you can think of, configuring your avatar to be the best expression of your creative self or to look just like you, right? And in mixed reality, we can have similar sorts of avatars, but on the other end of the spectrum, we can also have high fidelity digital representations of ourselves. We can use things like holographic capture to fully capture your physical self and render you in the digital world with the true likeness. Once we've decided how we want to represent ourselves in immersive mixed reality, for it to be immersive, we probably need to be able to interact with other people, which means that we need to be able to have some sort of shared session context that allows us to interact and collaborate with others. We also need a way to be able to relay information between those people in the shared session context for us to feel that we are together immersively. For example, if I move my hands in the air, on your device, what should happen is that my avatar's hands should be rendered as moving in the same way that my own hands were moving. This requires us to transmit in high quality and in real time information about my avatar pose changing to your device so that your device can render it appropriately and quickly. On to the next pillar. Experience together, rich volumetric content. Well, what kinds of content specifically are we talking about? Well, the first class of content would be 3D assets and models that are able to be locally loaded and rendered on your device. Think assets and models with relatively low polygon counts that have a low memory footprint and don't require too much CPU to render in full. So in this example, we have a teacher on her HoloLens interacting with a molecule, and you can also see the students seeing her interactions with that molecule as well as the methane molecule that's in the space on their own devices. Now, what about 3D assets and models that are either too large to render on device or too complex to render on device without requiring a lot of decimation, or even with a lot of decimation are still too complex to render on device? What can we do there? Well, that's the second class of assets. These are assets that are either very large or require very high fidelity in order to interact with them. A great example here would be, MRI scans or some other bodily scan that is taken of a patient and needs to be rendered with ultra high fidelities to the surgeons who are prepping for a surgery. As an individual, if I were a patient and I'd had all my insides scanned, I would be very upset if any part of my insides were decimated before they were shown to the surgeons that were meant to operate on me. It would be very important that every detail be rendered with accuracy and ultra high fidelity to those surgeons so they could do their jobs effectively. In order to do this, we would leverage the power of the cloud and a solution like Azure Remote Rendering, which allows us to render complex models using the compute power in the cloud and stream those renderings to the devices. This allows us to render more complex models on a very wide range of devices. And the last set of content that we can experience together is dynamic content. This is content that is either live or pre-recorded that needs to be broadcast to many users at the same time. But in order for them to experience this content together, they also need to be seeing it together. This means the broadcast needs to be happening at the same time to all of these devices so that they're all seeing the same thing at the same time. Now, the third pillar we talked about was being able to connect from anywhere. We want to be able to target immersive and collaborative experiences to the broadest audience on the widest range of devices and platforms. When we say anywhere, we also mean from anywhere in the world, right? I should be able to have a seamless, immersive mixed reality experience from Lagos with people in San Francisco, people in Seattle, people in Abidjan, people in New Zealand, people in Dubai. I think you get it. From everywhere in the world, we should be able to have these experiences so we can truly feel like here can be anywhere. So, now we're all on the same page for what we mean by here can be anywhere when we talk about the vision for immersive mixed reality. But how do we bring that vision to life? Let's walk through a case study, the immersive mixed reality concert. How do we make something like that happen? So, a bit about me. I love live music and I love going to concerts. It's one of my favorite things to do. Unfortunately, during the pandemic, this has been very difficult to do for many reasons. Now, virtual concerts have been a thing since before the pandemic, but my first time attending one was during the pandemic. And it was a concert by one of my favorite artists, Burna Boy. It was such an incredible experience to have Burna Boy singing in my living room. I was shouting and dancing and singing along. I'm sure my downstairs neighbors did not love me, but I had a great time, which is all that matters, right? During the concert, I was calling friends and family who were also streaming the concert, and we were trying to experience that together. But we ran into some snafus. Sometimes the concert wasn't playing at the same time for all of us, but in the end, it was still okay. We got a great concert by Burna Boy with some amazing music. We got to share our joy and excitement with each other, and it was a really bright spot during that time for me. But how can we take that experience one level further? How can we make that an immersive mixed reality concert that's closer to what in-person concerts used to feel like? How can I really bring in the presence of not only my friends and my family that I had called, but also other Burna Boy lovers who want to share their love for Burna Boy with other people? How can we ensure that that broadcast lag doesn't affect how we experience things together? Well, I'll walk through 3 of the challenges we might face trying to make this mixed reality concert happen, and some of the things that we do in the face of those challenges. So the first challenge we'll talk about today is how we scale the interparticipant data relay. If you remember from earlier, we were talking about the necessity of high quality, real-time interparticipant data exchange. Remember, when my hands move, my avatar's hand should move on your device. This is key to enabling realistic presence. Another key thing beyond our avatar data is also audio data. Tinny voices through a phone don't really enable realistic presence in the same way that something like spatial audio would. If your avatar is behind me and your voice sounds like it's coming from behind me, it really feels like you're there with me, right? It feels like you're present. If your avatar is to the left and your voice is coming from the left, it feels like you're present. It feels like you're really there. Now, relaying this data between a couple of participants, pretty easy to do, right? Being able to share all of the spatial audio data and this avatar pose data in meetings of 3 or 4 people, easy to do. But this is Burna Boy. He's got hundreds of thousands, millions of fans. And this immersive mixed reality concert, we're not talking about 3 or 4 people. We're talking about millions of people. This creates a real challenge. Imagine that the data that I need to relay is just 1 byte. It's not, but imagine that in order for me to relay all of my sound data when I speak to you and all of my avatar motion data, I just need to send 1 byte. Now, imagine there's a million people at this Burna Boy concert. That's a terabyte of data that we need to send around, right? Because I need to send my data to all of the other users, and all of the other users need to send their data to all of the other users. This is an n squared problem. It's too much data to be sending around efficiently. So what can we do? Well, what do we generally do when we have too much data? We zip it. I'm sure everybody here has either received a zip file or zipped a folder in order to send it because the original folder was too large. Compression is the name of the game, and we can use it here as well. When we compress the avatar skeleton data, we have fewer bytes that we need to move around. Here's an example of an avatar compression algorithm where we see the original avatar skeleton motion next to the compressed data. As we can see, there's not too much data that we lost when we compressed. The avatar skeletons are moving in very similar ways. And that's great. We're able to capture the majority of the avatar's motion, but we've greatly reduced the number of bytes that we need to be sending around. But there is a difference here, right? This is a pretty aggressive compression algorithm, which means that we lose some data. We lose some fidelity to the original avatar skeleton's movement. Well, in some cases, that could be okay. In other cases, we're much more sensitive to the data loss, so we don't want to be using compression as aggressively. So in those cases, we can actually optimize our relay based on proximity. If we sync to a real-life concert, and there's many, many people around, you can see with great detail how the people directly near you are moving. You can probably hear them a bit better. You can see their facial expressions. You know exactly how far their pinky is from their ring finger, if they're waving their hands in the air. Your eyes can see all of this when people are very close to you. But what about the case for a concert goer that's much further away from you? When they're waving their hands in the air, you can see that they're waving their hands in the air, but you can't necessarily see all of the details. You don't really know to the millimeter how far their ring finger is away from their pinky finger. And you don't really need to know. We can apply this same optimization when we're creating things in immersive mixed reality. In this case, we can optimize our compression algorithms for avatar data based on where those avatars are relative to you. That is, the avatar compression algorithm we saw previously might work great for avatars that are further away from you, and we can probably tolerate the loss from the original data there because, again, if they're further away from you, you don't really need all of the details. And we can choose to leverage a less lossy compression algorithm for avatars that are much closer to you. We can do the same thing with audio data as well, right? It's important that you know the details of the spatial audio data of those that are near to you, but less important that you get all of the details for that audio data from avatars that are further away from you. So here we've started to address the data problem at scale by compressing where we can and optimizing which data we send and how we send it based on proximity. Great. So our next challenge, co-location. Imagine that some of us are physically co-located at this concert. That is, some of us are actually in the same room at this mixed reality concert, and others are virtual to us. They're not in the same room. What changes? So let's go back to the Burna Boy concert scenario. This time, I have a couple of my friends over to experience the immersive concert with me. Some of our friends are still virtual to us, and also all of the other concert goers are still virtual to us. But there's a group of us that are physically together in the same room. Well, one thing we can do here is actually optimize a little bit. If you're physically in the same room with me, I don't need to feel your immersive presence digitally because I can feel your physical presence physically. I don't need to relay my avatar data or my spatial audio data to you because you're in the room with me and you can experience that physically. But having you there with me also makes things more difficult and more complicated. Imagine, if you will, that this time around, Burna Boy has some sort of, virtual t-shirt cannon, and he's spraying the crowd with t-shirts. Pew, 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 pew. And amazingly, one of these t-shirts lands in my part of the concert, in my living room. But where in my living room? If I see it on the couch and you see it on the coffee table, somebody else sees it on the floor, somebody else sees it on the TV stand, we're not really experiencing that t-shirt together. We all have individual experiences of that t-shirt, but it's just one t-shirt. We should all see it the same way. So when Burna Boy shoots that t-shirt and it lands on my couch, we should all have to dive to the couch to grab the t-shirt so that we're all experiencing the one t-shirt in the same place. Well, how do we do this? What do we need to be able to line up the holograms so that everybody that's in my living room sees that hologram appear in the same place? Well, this actually requires an understanding of not just the digital environment we've created in this shared space, but also the physical environment that we're actually sharing, right? The immersive mixed reality concert needs to know what my living room looks like so that when it lands on the couch for one person, it lands on the couch for everybody. How do we do this? Azure Spatial Anchors already does this for us. It leverages the power of computer vision to help make a global map of the world in the cloud. That way, my couch has meaning for all of us that we share, right? We're sharing in this immersive mixed reality concert a shared understanding of my living room so that when that t-shirt flies in, if it lands on the couch, we're all going for the couch. Just like we were able to leverage the power of the cloud to remotely render things instead of locally render things, we can leverage the power of Azure Spatial Anchors and use a cloud-based understanding of our physical environment that we can all share rather than using an individual device-based understanding of the space around us. Great. So, the next challenge we'll talk about is how do we actually scale the concert? How do we get Burna Boy's performance to everybody? Well, one option would be to just have Burna Boy and his DJ send their data to a server and have all million people try to connect to the one server and stream all that data out. It's not going to work. This design is great for smaller scale events, but again, this is Burna Boy. Hundreds of thousands, millions of fans, all trying to experience this concert at the same time. How do we do this? How do we scale the performance to many, many users so that they can all experience it at the same time? Well, one approach we could take is to use a tiered broadcast topology. In this case, our performer, here Mixmaster Mike, will stream his performance to one root node. That root node then forwards the performance to many edge nodes around the world, and then consumers get load balanced across these edge nodes and placed on the edge node that makes the most sense based on where they are geographically for them to have an ideal experience. Now, we're able to scale to many, many more consumers of content, And should these edge nodes get taxed, we can add new edge nodes, we can add a middle tier, but we're able to scale out this system and still allow everybody to experience the concert at the same time with low latency from the original broadcast. This is great. We've solved our many consumers problem, but we have different types of consumers. Remember, when we said here can be anywhere, we said anywhere in the world, but we also said any device and any platform. Here, we've addressed the anywhere in the world problem by geo-distributing our nodes. How do we address the many devices problem? One approach here would be to use heterogeneous stream broadcasting. We would have our performer produce streams of different sizes. Let's say a 2 megabit per second stream and then a 5 and a 15. Then we allow consumers to consume the stream that makes the most sense for the device capabilities. My phone is going to be really happy with the 2 megabit per second stream, whereas my HoloLens, my wrist, my laptop might prefer the 5 or the 15. This allows us to have great experiences on many different types of devices. So now let's bring this all together. We figured out a way to relay the data between the many concert goers in a way that is efficient and scalable and allows people to feel each other's presence immersively. We've also understood how people in my living room can still interact with the concert content in a way that ensures we're experiencing things together both in the physical and virtual worlds. We've also figured out how we can stream the concert performance to many devices across many different geographic locations, across many different form factors. Well, what does this look like in practice? Let's take a look at how Mixmaster Mike, Colocation, and AltSpace brought this to life. The Mixmaster Mike Mixed Reality Concert gives us a small taste of the incredible immersive mixed reality experiences that we enable when we bring the here can be anywhere vision to life. We feel each other's presence. Avatars are dancing in the room together, able to share their joy brought on by Mixmaster Mike's musical genius. They're also able to experience that content together. They're dancing, they're on beat. And when they're not on beat, they, like me, probably wouldn't be on beat in real life either. They're experiencing that content together and they're connected from anywhere and everywhere. Their phones, their laptops, their head mounted devices, from Lagos to Seattle to San Francisco to New Zealand. Here can be anywhere, and you can be a part of it too. There are so many opportunities to get involved in realizing this vision. I only touched on 3 of the challenges that you might face to enable a single scenario. So no matter your area of interest, there's a place for you in bringing this vision to life. Thank you so much for taking the time today to share in my enthusiasm and excitement about mixed reality. I'm happy to take what questions I can.